Hi class, I want to take a moment to discuss Icmp. You probably realize that the use of Icmp tools or troubleshooting tools are based on using those messages. So it's about they're valuable tools, but likewise this is a method that can be used for attacks. So Icmp provides vital feedback about the IP routing and delivery problems. Icmp also provides important IP diagnostics and control capabilities that include reachability analysis, congestion management, route optimization, and timeout error reports. Although Icmp messages fall within various well-documented types, um, and behave as a separate protocol at the TCP/IP network layer, Icmp is really part of IP itself, and its support is required in any standard compliant IP implementation. With that, the RFC 792 describes ICP, but numerous other RFCs, such as the 950 or 1191, etc., describe additional details about how ICP should behave and how its messages should be generated and handled. With that, then, both IMCP version 4 and IMCP version 6 messages are organized into two general types. You have your error messages and your informational messages. Many of these messages are similar in both versions of the IMCP protocol, such as the echo request and the echo reply messages, the PMTU discovery, router solicitation, and router advertisement, and traceroute. Others, such as the packet too big and router renumbering, are completely new with the IMPC version 6. Two of the TCP/IP diagnostic tools are the ping and the traceroute, invoked as trace RT in the Windows environment. They use IMCP to measure round-trip times between sending and receiving host and to perform path discovery for sending hosts and all the intermediate hosts or routers between the sender and the receiver. IMCP also supports the PMTU discovery between the sender and the receiver, which optimizes the performance of data delivery between pairs or by hosts, avoiding fragmentation in route. This occurs by establishing the smallest MTU required for the path between the sender and the receiver, and then transmitting all datagrams of the size or smaller from the sending host. Icmp version 6 then introduces numerous changes to the MTU management and the PMTU discovery, such as the default IP version 4 packet MTU being changed from 576 bytes to the 1280 byte for IP version 6. And then the IP version 6 routers do not fragment packets, so that the sending host must use the PMTU to establish the smallest unit, MTU in PMTU, and then impact the correct packet MTU to messages before transmission. If IP version 6 packet is too large for link MTU, router will send an Icmp version 6 packet too big message to the source node, and the node will respond by reducing the MTU of the packet and resending the message. Route and routing error information from the ICMP derives from numerous types of IMCP messages. These are going to include the ICMP router solicitation messages, which hosts use to locate routers, and the ICMP router advertisement messages, which routers use to advertise their presence and capabilities, as well as the various codes for the ICMP destination unreachable message, which documents many possible causes for delivery failures. So with it then, it supports route optimization through the ICMP redirect message type. Security issues are important. Message structure and functions can vary between the two, and ICMP version 4 and ICMP version 6 echo messages have a similar format, so there's very little differences. I hope this has helped you, and we'll go from there.